Okay, today I'm going to present about my comprehension about error analysis. Okay, error in physics, in measurement, we always face this kind of error. We always face error because it is mistake that we can avoid. Because usually our apparatus, we have some problem with our apparatus and so on. So there is two types of the error. First is random error. Okay. Random error is the error that has a probability to happen half, and probability to not happen is half. This is what I understand. For example, like uncertainty in our measurement. Sometimes the measurement can be half more than our ni. Sometimes our measurement can be less, half meter, something like that. And then second type is the systematic error. Okay, systematic error. For systematic error, usually we can really detect it by our readings. We cannot see clearly because from the beginning of experiment and to the end of the experiment, the systematic error has caused our result to be different from the actual value. So it really hard to detect the systematic error. So usually things that we do to avoid the systematic error is we really take extra careful in our steps and calculation. We avoid for certain experiment that need to obey a certain condition, we will really obey the condition. We will make the arrangement of experiment, follow the condition. Okay. Then I forgot to tell about random errors. Okay, random errors, like what I said, it has probably to happen half and not happen half. So in our experiment, these random errors, interestingly, we can detect it in our measurement. Okay, in our experiment, error analysis, basically what I see is we more focus to random errors because yes, in experiment we usually deal with the random errors because systematic error we will deal with, we will avoid it clearly from the beginning. So in the measurement, usually we will deal with the random errors in our analysis. Okay, so what we do is we can get a better picture of the random errors with doing many samples. Take many measurement to reduce the random errors that occur in our experiment. The best thing is we can picture it. We can get the picture by writing the graph. Okay, by writing the graph, you can see how random errors is affecting the reading, because by doing the graph we can see the best how the random errors is actually affecting the result to distributed from the true value. Okay, if our significant errors, we really deal with it properly from the beginning of experiment, then our graph usually, okay, for I explain. Sorry, I forgot to tell. The graph is Gauss. We write the histogram graph and then we draw the Gauss line. If the Gauss line is wider, and then there is significant systematic error because we has done in this experiment we has done 3020 times. So basically it's not logic to have such